Multi-factor authentication with ADFS. When we're dealing with multi-factor authentication with Office 365 and ADFS, we have two options for where we want the MFA to occur, either on-premise or in the cloud. If we walk through a simplified authentication workflow with ADFS, first we try to access the resource at the relying party, in our case Office 365. We type in our username, and it immediately determines that our domain is federated. This is sometimes referred to as realm discovery. It's sort of a DNS agnostic way of saying that our user object belongs to an external account partner organization. For our purposes, the realm is pfslab.com. Once the realm is determined to be from a federated identity, we're forwarded to the federated endpoint for authentication, in our case an ADFS endpoint. Now, if we have an on-premise MFA solution such as a server or plugin, then this is where that takes place. ADFS will authenticate us against Active Directory as the first factor, and then engage the on-premise MFA provider as the second factor. Don't worry so much about the mechanisms, we'll get to that. Just understand that both factors for an on-premise solution are handled by ADFS. If the user successfully clears both factors, then a token is generated and sent to the client to present to the relying party, who then gains access to Office 365. If we prefer, we could choose not to perform the multi-factor authentication on-premise and enable MFA in the cloud. This is the same type of MFA that we worked with back in Objective 2 and managed through the Office 365 Admin Center. We can deploy either of these, or we could technically deploy both, but we would have to take certain precautions to prevent someone from getting hit twice with MFA requests, and we'll talk about how we can accomplish that too. Next, let's talk briefly about what the differences are between MFA on-premise and MFA in the cloud. For our purposes, I'm going to assume that we're using Microsoft's MFA server as the on-premise solution, but there are other third-party MFA providers as well. Also, as we talked about in Objective 2, there are additional MFA capabilities to the Azure MFA Cloud solution if you have a premium account. In fact, both the second and third column require additional paid services. Only the first column comes free with Office 365. As you can see, the benefits of going with an Azure Premium Edition of MFA in the cloud is the added capability of fraud alerts, MFA reports, one-time bypass, custom greeting for phone calls, and trusted IPs, meaning IP addresses or ranges that will always bypass MFA. And this is most likely used for your internal corporate network, but as we'll see, we can accomplish this another way with claims rules. Picking a server gives you even more flexibility. An on-premise server can be used to enforce multi-factor authentication for non-Azure applications, meaning there could be other on-premise or cloud-based applications other than Office 365 that can use the MFA server or rely on ADFS, which can enforce MFA as well. The MFA on-premise server also supports hardware tokens, where the Azure Cloud MFA does not. A downside to using the on-premise server, however, is that it doesn't support or issue app passwords. This means if you have an application that doesn't support forms-based authentication or modern authentication, then you will probably have to write a claim rule to bypass MFA altogether. Here's a diagram of the integration of on-premise MFA solutions with the ADFS claims engine. In the previous lesson, we saw a graphic of the acceptance rules, authorization rules, and issuance rules all next to each other. I've split that graphic out to show you that there are in fact some additional rules and processing that takes place between the acceptance rules from the claims provider trust and the authorization and issuance rules from the relying party trust. These new rules are called additional authorization rules, and this is where MFA policies can be set either globally or per relying party. Some of these rules can be defined in the authentication policy screen in the ADFS management utility. Custom rules, however, have to be added via PowerShell. If any of these rules result in the issue of a claim that has authentication method equal to multiple authn, then that means the on-premise MFA provider should trigger second-factor authentication. If this claim is not present, then the MFA is not engaged and execution continues to the authorization rules. When the MFA is engaged, if it's the Microsoft Azure MFA server, it sends the user info to Azure to perform the MFA. That means nothing on-premise is actually making phone calls or sending text messages. That's all being handled by Azure in the cloud. If the second factor is successful, another claim is issued called authn method references, and the value is changed to multiple authn. This signifies that MFA has been performed and was successful. It is this way that Cloud MFA, if also enabled, will not prompt the user for second-factor authentication again. It can tell by the claim that it was already complete. This means we can artificially set the claim when we want to bypass Cloud MFA for an enabled user, because Office 365 and Azure will think that the MFA has already been performed on-premise. Be careful not to mix these two up. They look very similar, but they do almost the exact opposite. Setting the first will force MFA to occur, while setting the second one will bypass it. Here is the workflow for the Cloud MFA in Azure. First, a token is received from a claims provider. If the user does not have Azure MFA enabled, then nothing happens and the user is let in. If the user does have MFA in the cloud enabled, then it checks to see if MFA has already been performed on-site by looking at that authn method references claim. If this claim is set to multiple authn, then no MFA is performed and the user gets to their homepage or their application. If this claim is not present or the value is not recognized, then the cloud MFA is performed before the user can get in. Again, setting this claim artificially can help bypass MFA. This slide shows some of the screens that a user might encounter when trying to authenticate with MFA. If we start down at the bottom, we're looking at a user trying to log in to the Office 365 portal. If they have ADFS with an on-premise MFA solution, it will be the STS page from the Federation server that will prompt the user for their second factor verification. If on the other hand we're using Cloud MFA, then they'll be brought to the Office 365 login page where they'll be prompted for their second factor verification. If they're using an application such as Outlook that supports modern authentication, then they'll get a white pop-up dialog from the ADAL DLL. This will prompt for user credentials and will also prompt for the second factor in both the on-premise and the cloud-based MFA scenarios. If the application does not support modern authentication, then we cannot use MFA. If MFA is in the cloud, we have the option of using app passwords, or we can use claim rules to bypass MFA for certain incoming applications. If we're using on-premise MFA, then we can't use app passwords, so we can only use claim rules. When we use claim rules, we can try to bypass MFA based on the application that is being reported, or we can alternatively use the authentication endpoint. Both portal logins and modern authentication logins are considered forms-based logins and are classified as passive login methods. There are only two endpoints that are considered passive endpoints, and they are the ADFS/LS for SAML and the ADFS/OAuth for JWT, which is the token type for modern authentication. Therefore, if we force these methods to use MFA but bypass MFA for all other endpoints, we can effectively require MFA where it's supported and bypass where it's not. All Office 2016 applications support modern authentication by default, but in the case of Exchange Online, there is a server setting that must be turned on for it to work. First, you need to connect to an Exchange Online PowerShell session and then run the following command: set-organization config -OAuth2 client profile enabled $true. You can check the current setting with a get-organization config. As for Office 2013, modern authentication is supported as of the March 2015 update, but you also need to set two registry settings manually. Both are in HKey Current User Software Microsoft Office 15.0 Common Identity. The first is Enable ADAL. If this key does not exist, you must create it and set the value to 1. Next is version, which also must be created if not already there and set to 1. For Skype for Business Online, you must first download and install the Skype for Business Online PowerShell module. It's something we have not worked with before. Once connected, you'll need to run the set cs-oauth config command with the -client adal auth override allowed parameter. You can use the get-cs-oauth configuration to check. There's nothing that needs to be done with SharePoint Online, and it supports modern authentication with no intervention. Here is a look at the screens in ADFS management for setting the authentication policy globally and per relying trust. The MFA settings here are what gets translated into the additional authentication rules and get enforced between the acceptance rules of the claim provider trust and the authorization rules from the relying party trust. Anything set at the global level will override anything at the relying party trust level. Also, these settings are evaluated in a kind of Boolean OR fashion, meaning if any of these settings would trigger MFA, then MFA triggers. An example would be if I said that the MFA was required for external users and also for me, Adam Dreyer. You might think it would only trigger for me and only when I'm not on the corporate network, but in fact it would trigger for all users externally and for me all the time. This is because it's evaluated as MFA is required when either condition is true, when the user equals me or when the user is external. If you want to use compound or more finely grained conditions, you can do so, but you will have to add them via PowerShell. Here is a sample rule to enforce MFA only on supported Outlook clients. As you can see, our first condition is based on the user agent value being equal to Outlook. The second condition specifies that the authentication endpoint is either ADFS/LS or ADFS/OAuth2. As we spoke about, both of these endpoints support MFA. Then the action is to issue a claim to set the authentication method to multiple authn. This means it will trigger MFA either on-premise or in the cloud. In order to add this rule to the current additional rules for the relying trust, we first have to set a variable to the existing additional rules for the relying trust. Then we'll append or concatenate our new rule to the end. Then we'll create a new rule set based on this string. This line isn't completely necessary, but it will throw an error if the rule format is wrong, and I'd rather it happen here than when trying to update a live setting in production. Finally, we call the set ADFS relying party trust command to set the additional authentication rules to a variable that now represents the previous existing rules plus our new one. For our last slide, I wanted to show you a screenshot of the Microsoft on-premise Azure MFA server. This was a product that was originally called PhoneFactor and was bought by Microsoft a few years ago. It's downloaded from the Azure portal, which we'll see in the demo. It can be installed directly on the ADFS server or as a standalone. If it's not installed on the ADF server, then a software adapter must be installed on the ADFS server to connect to it. It comes with its own user portal that requires IIS to deploy, and this will allow users to register and change their second factor information and preferences if that's what you want to allow. Or it can give you granular control over the methods and enforce a particular one if you prefer. It also supports hardware tokens as a second factor, pins, and two-way text messages, where the user must reply to the text. As previously mentioned, it sends the MFA request to Azure in the cloud, so it must have the ability to speak to Azure over the internet. It also has a bulk emailer with customizable templates, so you can send messages to your enrolled users regarding MFA. Okay, let's take a look at ADFS multi-factor authentication.